All right, so here is practice lesson 5.1. It's all about side, side, side angle congruence. And the first thing is to figure out what length of these are used in this triangle. I'm going to use a ruler instead of patty paper because I like rulers instead. Right, so I'm going to use this one. I'm going to line up the 0 centimeters. I like to use centimeters because they're really a little bit more precise. And I'm going to say that this one to the center of this one is about 5.3 centimeters. And I'm gonna make this one red. I'm going to say it's about 5.3 centimeters. Okay, centimeters. All right, then I'm gonna go over to, purple. We'll use purple for T to R. T to R is nice and flat, and I'm gonna go ahead and say that one is about 2.4, it's like 4 or 5. I'll be super precise. It's like 2.45. Usually you can measure between units. That's the most precise you can get. So this is let's say 2.45 centimeters. And then the last one is orange. We'll go with orange, and this one is, I'll look sideways, is about, I'm going to say it's right there at the intersection of 3.6. 3.6 centimeters. I'm trying to go center to center, so 3.6 centimeters. 3.6 centimeters. I'm just going to round this one up so they're all the same, 2.5 centimeters. Okay, so now I got to go and find which ones match which. Okay, so I'm going to go and look for 5.3 centimeters here. So that one's 5.3 centimeters right there. 5.3 centimeters. So this one is my red one. 5.3 centimeters is this one right here. 5.3 centimeters. This is WR. WR is congruent with 5.3. Okay, and then we'll find 2.5 centimeters. That's my purple one. It's too, you can't see, that's too short. That's pretty good. That's pretty good. That was like 2.45 last time, but that's gonna be, this is TR. So that's congruent with TR. And then we're gonna have 3.6. I forgot units. Units are important. All right, centimeters. So let's see, this one was 3.6. It's gonna be around like right here or something. That one's too long. That one's just about right. All right, so that one's this one. All right, so this is this one here is gonna be WT. All right, so going down to here. Number 1 WT was GH. RT was CD. And then GH was MN. MN. Okay, now that says to reconstruct the triangle. Okay, so I'm going to go ahead and reconstruct this triangle. I got to start with my purple base, and that was 2.5 centimeters. 2.5 centimeters. 2.5 centimeters. But I need something else. It says using the line segments that have the same thing, but I probably need something else if I wanted to be more precise. 2.5 centimeters. What I need, this is, and then I need to name this triangle WRT, right? Remember this TR was my purple one. So RT, this needs to be YZ, because R is here, so Y is R, and then Z is T. So this is Z. Alright, so but I need to also figure out at least one angle on this, because one angle will help me with the rest of this stuff. So if I go here, I need something flat, maybe like a card. I'll use this card here, right? So this card here is going to help me extend my protractor so I can read it very, very, very. I'm gonna get this angle WTR. It's going to be over 120 degrees. I make sure that my protractor is reading Westcott, right? It's not backwards like that. Right, I don't want it to read backwards, but I'm gonna go like this, and I'm gonna flip my protractor like this. Make sure that it is, see this little T right here, little T. I gotta make sure that the point is right in that little hole, and that my line is as close to centered on the line right here. Okay, and then I'm gonna take this and try to line it up perfectly with that, right? And then it looks like that my angle is going to be reading at about 115. So this is 115 degrees. Okay, so I need to do that. I need to make this 115 degrees right here. So I'm going to do this. I'm going to do this right here. I'm going to put my point right here. Line it up there, and then I'm gonna get my orange pen out. I'm just gonna start my angle. At 115. Right there. Seems to be my angle. Right there. 115. So I'm going to kind of slide this over, right? I'm going to put it so it's on my line, right? Center of my line, and rotate that to 115. Okay, 115 right there. And then just make sure I start my angle. Just got to start it. 115 there. And then this has to be 3.6 centimeters. So 3.6 centimeters from where it started. 3.6, right about there to the end point. Oh, you can't see it. There we go. 3.6 centimeters to right about there. And then this would be point X. This is going to be point X. And then my red mark, if I did everything correctly, this should be in and about 5.3 centimeters. Should be about 5.3 centimeters if I did everything right, because this is 3.6 centimeters. And this is 2.5 centimeters. All right, so it should be pretty close. So if everything's the same and everything's congruent, this should be pretty close to 5.3 centimeters. 5.3 centimeters. Put my dot up here. Let me put my mark up here. And let me put a mark down here. Okay, because there was a little bit of wiggle room in there because of the mark. So 5.3, hey, look at that. It's pretty close to 5.3 centimeters. So that was my red mark. Of course, there's going to be a little bit of margin for error. you know, because it is hand, and but it was pretty close, right? So this is 5.3 centimeters, right? And I named the new triangle XYZ. All right, so that is the first. That's the first page. All right, the second page is complete the statement that three sides of the triangle WRT are congruent with the three sides of the triangle because WT is congruent to X and Z. Is congruent to X and Z, right? And then we're going to say that the RT is congruent to Z. RT is congruent to Y and Z. It's congruent to Y and Z. Maybe I should be color coding that. Yeah, let's color code that. X and Z, and then it should be Y and Z is purple, congruent to Y and Z. This is congruent to Y and Z. Y and Z. And then finally W and R. W and R. W and R is congruent to X and Y. Congruent to X and Y. X and Y. Okay, and then we have to say determine if your angles are congruent. Explain how you determine your angles. Right? Well, since you have that WRT, you have angle WR. I need to put this in there so you can see it. WRT is congruent to angle XYZ by the side congruence postulate. Because all three sides are congruent. Therefore, all three angles are congruent. Okay, so that's just the congruence postulate. All right. So here we have, next question is, here we have a series of triangles, right? Or of transformations applied to line CH. Line CH, I should do that with a line CH. Line CH. Line HN. Line HN. Line HN. Line HN. And then line, let's use pink this time. And line NC. Line NC. NC. Okay. All right, now we're going to complete these statements. All right, so let's just go ahead and mark up our. Let's make this one a little bit more apparent. Okay. Well, it looks like we have. That's ugly. Whatever. Okay, so it looks like H and N went to T and R. Okay, and then H and R, and R and T. R and T. R and T went to. Got transformed. Let's see. It's like the first one was a translation. Everything just got translated first. Yeah, everything was translated first. So first one, and then the next one was orange. Yeah, next one was orange, and then yeah, so and then this one went to MT, and then the pink went to RT. Okay, so we had a triangle, got translated first, so everything was just moved over, and then it looked like it was something was rotated 90 degrees clockwise. So you see this 90-degree thing here, right? And it looks like it rotated this way, clockwise. So then it looks like that this PW, RT became PW, and then MT became FW, FT or MT became FW, and then PF or MR became PF. That's what it looks like, and I think that's pretty sure what happened. All right, so the first transformation applied to this triangle. All right, so I'm gonna go ahead and make some congruence marks to make it easier to follow. Let's do that in blue. All right, so HN, and that one are congruent. And this one, this one, and this one, and this one, and then this one, and then this one, and this one. Those three. Okay, so that is pretty certain that's what happened here. Okay, so we had, wait a minute, that should be a 2, and this is a 1. Somehow I got changed up. This is a 1. Okay, so yeah, 1, 1, 1, 2, and then 3. That rotated. Yeah, pretty sure that's what happened. This is an orange. This is an orange up here. Okay, this is not obvious. Okay, yeah, so these got transferred over. That's wrong right there. It should be a 2. There we go. There we go. That's better. All right, so there we go. All right, so that's what happened. Those are the congruent sides. So the transformation was applied. The first one that was applied was a translation. So this is a translation. Okay, this results in CH being congruent to MT, and then HN being congruent to RT, or TR, if you want to be technical about it, and then RM being congruent to, or NC being congruent to RM. And then next, therefore, the definition of congruence, just by the definition of congruence, the two triangles are congruent. Yeah, so HNC is congruent to TRM. Okay, the second transformation applied is a rotation of 90 degrees. Is a 90 degree, well, yeah, it's 90 degrees. 90 degrees clockwise rotation. This results in MR, which was, yeah, it was pink, MR being PF, or FP, if you want to go the same way, RT being PW, and TM being FW, that's orange, being FW, and therefore by the definition of congruence again, by the definition of congruence, GRUENCE, you have to match up the the points now here to make sure that you got it right. So T, R, M, this goes across the purple, across 2, across 1, and across 3. So across 2, across 1, and then across 3. So this would be WPF. So this would be WPF. So WPF. All right, so that is section 5.1 homework. Hope that makes sense to everybody. Thanks.